In the next question 164, which is based on a radioactive decay, it says that half-life of a radioactive isotope X is 20 years and it decays to another element Y. You see here the situation is that X is getting decayed into Y. The two elements X and Y were found to be in the ratio 1:7. Sometimes you see 1:7 ratio is there. Now you see when X is getting decayed into Y, so whatever 7 part of Y is there, initially if you see 7 plus 1, that is 8 part you had X and 0 part was Y. You understand? You add both of them, so that gives you the initial state. So initially X was 8, after one half-life it must have become 4, and after another half-life it is 2, and after next half-life it is becoming 1. So total life is 3 half-life. You understand? This is the age. It is demanding the two elements, that is in the ratio in a sample. The age of the rock is demanded. Age of the rock is 3 half-life, and you see each half-life has been given to be 20 years. So this is 3 into 20, that is 60 years will be the age of the rock. So most appropriate answer will be the first one for this particular question. Let us look at next question, that is question 165. In the next question 165, which is based on current electricity and that too Wheatstone bridge, it says that resistances of the 4 arms P, Q, R and S in a Wheatstone bridge are 10, 30, 30 and 90 ohm. So if you are looking at the solution of this particular Wheatstone bridge, you see here it is 10 ohm, 30 ohm, this is 30 ohm and 90 ohm that has been given to you. You see 10, 30, 30 and 90. The EMF and internal resistance of this cell are 7 volt and 5 ohm. So EMF is connected here. This is 7 volt and internal resistance has been given to be 5 ohm. If the galvanometer resistance is 50 ohm, now you see, try to check whether it's a balanced bridge or not. So you can clearly see it's a balanced bridge. Even if you are adding galvanometer here, you see that is becoming immaterial. You understand why? Because 10 by 30 is same as 30 by 90. So whatever is the value of this galvanometer, you can simply disconnect it from the circuit. And now this is the kind of situation. You are supposed to find out the current drawn from the cell. That means what is the current which is flowing here. So here you see 10 and 30 they are in series, that is 40, and here 30 and 90 they are in series, that is 120. So overall resistance will be of this entire thing is 40 into 120 by 40 plus 120, isn't it? 40 into 120 divided by 40 into 40 plus 120, that makes it 30 ohm. And this 30 ohm will be in series with this 5 ohm, so total makes it 35. And if you are trying to find out the current, this will be 7 volt divided by this 30 plus 5, that is 35 ohm, and that will make it 0.2 ampere current flowing into the circuit. So for that matter, the most appropriate option you can see, this is 0.2 ampere, which is the first option for this particular question 165. Look at next question, that is question 166. Now the next question 166, which is based on thermodynamics and that too on graphs. Here in the given VT diagram, they are demanding what is the relation between this pressure. So you see in this particular question, you can straightway start off from the ideal gas equation, that is PV is equal to nRT, and here it is V by T graph. So what you see here is V by T is nR by P, and V by T is basically the slope. So you see here, whichever graph will be having larger slope, that will be having smaller pressure. So here you see the larger slope is for P2, so the value of P2 will be lesser, and for that matter P2 will be lesser than P1, and most appropriate answer for this particular question will be the second one. So that was question 166. Let us look at next question, that is 167. in the next question 167, which is based on kinetic theory of gases and very straightforward formula based question. Rather, whatever has been demanded here, that is directly used as a formula as well, anywhere found in our packages. You see, they are saying the molar specific heats of an ideal gas at constant pressure and volume are denoted by Cp and Cv respectively. If gamma is equal to Cp by Cv and R is the universal gas constant, then Cv is equal to, they are demanding the expression for Cv. Here in this particular question, you see, you can use this Mayer's relation that Cp minus Cv is equal to R. This is one equation you can use, and anyway Cp by Cv is given to you gamma. So in case you replace Cp, that is gamma Cv, that you substitute here, and ultimately you will get Cv is equal to R upon gamma minus 1. This is the very standard expression, in fact used as a formula. So you should have used here the first option as the appropriate option for this particular question, and that was the question 167. Now let us look at next question, that is question 168. Here the next question, question 168, which is based on thermodynamics and concepts of kinetic theory of gases. They are requiring the amount of heat energy required to raise the temperature of 1 gram of helium at NTP from T1 Kelvin to T2 Kelvin. In this kind of question, you can straightway use the formula. You see, whatever heat is required here, that is equal to NCV delta T. This is a kind of formula you can use for heat given to the system at NTP to increase its temperature. Now N is number of moles. You see, number of moles, it is talking about 1 gram helium. So that makes it 1 by 4, isn't it? And CV for monatomic gas, that you know, that is equal to 3R by 2, and delta T is T2 minus T1. So that makes it 3 by 8 R T2 minus T1. And for R, that is universal gas constant, they are using the options, that is Avogadro number multiplied by Boltzmann constant. So anyway, R is defined like that, so you can very well write that way, 3 by 8 Avogadro number multiplied by Boltzmann constant and T2 minus T1. So for that matter, the most appropriate answer comes out to be the fourth option for this particular question 168. Look at next question, that is question 169. Now the next question 169, which is based on ray optics and that too calculation of power. It says that a plano-convex lens, that means this kind of lens you have. It fits exactly into plano-concave lens. Plano-concave lens is like this. Two different lenses you have. If lenses are made of different materials, let's suppose one is made of, say, refractive index mu1 and another one is made of refractive index mu2, and R is the radius of curvature of the curved surfaces of the lenses. You are keeping the lenses in contact, so their power will be getting added, and they are demanding what is the focal length of the combination. So first you calculate the power. If you talk about power, you will be saying, say for one lens it is mu minus 1 by R. If it was convex lens, the power was positive. If you talk about the another power, so that will be in terms of minus, because it's a concave lens, that is mu 2 minus 1 by R. You understand? So the combination will be having the power P, that is the sum of these two, and ultimately it will be, you just subtract these two, like mu 1 minus mu 2 upon R. And in case they are demanding the focal length of the combined thing, that is just inverse of that, and for that matter you will be writing it as R upon mu 1 minus mu 2. So this will be the answer for this particular question, and for that matter the most appropriate answer comes out to be the option 2. So that was the answer to question number 169. Let us look at next question, that is question 170. Now the next question 170, which is based on thermodynamics and that too adiabatic process. They have given you, during an adiabatic process, the pressure of a gas is found to be proportional to the cube of its temperature. You see, in this particular question it has been given to you, pressure is directly proportional to cube of the temperature. Now they are demanding what is the ratio of Cp by Cv. Cp by Cv, that means gamma for the gas. Now if you go by the usual relation, you have seen that we happen to say T raised to the power gamma is proportional to P raised to the power gamma minus 1. This is the usual expression so long as adiabatic process is concerned. And if you again try to simplify this thing, you are trying to say P is proportional to T raised to the power gamma upon gamma minus 1, isn't it? And if you compare these two, they are trying to say that gamma upon gamma minus 1, this is equal to 3, and for that matter gamma, which is Cp by Cv, you happen to say that comes out to be 3 by 2, and for that matter you will find that the most appropriate answer is answer 3 for this particular question 170. Look at next question, that is 171. In this question 171, which is based on progressive wave equation, that is sound waves, a wave traveling in the positive x direction having displacement along y direction as 1 meter. This is a kind of question which is directly formula based. You are expected to mark the equation of traveling wave. It gives you the amplitude 1 meter, wavelength is given, and the frequency is given. If you look at the general format of the equation, it is y is equal to a sine kx minus omega t, you can say. It has been mentioned that the wave is moving in positive x direction, that's why I have used minus sign here. Now all you have to do, you have to make substitution for a, k and omega. Now see, it is saying that it is having displacement along y direction as 1 meter, so instead of a I am writing 1, then it is sine k is related to wavelength, that is 2 pi by lambda. In case you make 2 pi by lambda, that is 2 pi by 2 pi, that is 1, so value of k comes out to be 1, so it is simply x minus omega is basically 2 pi into frequency. If you make 2 pi into frequency, frequency has been given to be equal to 1 by pi, so 2 pi into 1 by pi, that makes it 2, and for time t. So if you are trying to match this expression, you find that the most appropriate option comes out to be the fourth one for this particular question 171. Look at next question, that is 172. In the next question 172, which is based on logic gates, you can see here this is a NAND gate and this is another NAND gate, but since the inputs have been clubbed together, so it is working as a NOT gate. It says that the output x of the logic circuit shown in figure will be, you have to find out the truth table for x. If you look at the logic, then you see here the first NAND gate is basically what, a dot b, and that is complemented, you understand, and finally it is getting into, this is a NOT gate. Try to understand, this is NAND and this is NOT gate. NOT again means what, again the complement of that, and that will make it a dot b. So this is working as a AND gate, isn't it? NAND plus NOT, that makes it AND gate. So most appropriate answer we should think as 2 for question number 172. Look at next question, that is 173.